Here we have a chemical equation. We have carbon solid plus oxygen gas, which means that carbon reacts with oxygen to yield or produce carbon dioxide gas. Because atoms are neither created nor destroyed in a chemical reaction, a chemical equation must have the same number of atoms on each side of the arrow. So here are the reactants, and here are the products. On the reactant side, we have one atom of carbon, and on the product side, we also have one atom of carbon. On the reactant side, we have two atoms of oxygen. O2 means you have two oxygen atoms bonded together. And on the product side, you also have two atoms of oxygen. This is considered a balanced reaction because you have the same number of atoms on each side. So here are the rules we need to follow when balancing chemical equations. First, you must have the same number of each type of atom on both sides of the equation. And we can only change the coefficients. So what are the coefficients? In this example, the coefficients are those numbers before the molecule. So the 3 in front of hydrogen gas and the 2 in front of ammonia are coefficients. These can be changed in order to balance an equation. What cannot be changed are the subscripts. These subscripts determine the identity of the molecule. If we change those, we'd actually change the identity of the molecule. So we cannot touch the subscripts. 4, the coefficients must be reduced to the least common whole number. For example, in this chemical equation, we've got 2 carbons in the reactants and 2 carbons in the products. We've got 2 O2, so that means 4 oxygen atoms in the reactants and 4 oxygen atoms in the products. So it appears to be balanced. However, these all can be reduced to the least common whole number, which is 1. So the correctly balanced equation would be carbon plus oxygen yields carbon dioxide. So even though it's balanced, it doesn't mean it's the right balancing. You need to make sure your coefficients are reduced to the least common whole number. So here's an example of an unbalanced chemical equation. We take an atom inventory. We find that we have 2 hydrogen atoms in the reactants. H2 means that you've got 2 hydrogen atoms bonded together. And the product, water or water vapor, is gas. In the reactant side, we have 2 oxygen atoms. But in water, we only have 1 oxygen atom. So this is not a balanced chemical equation. Because Dalton's law says that atoms are neither created nor destroyed in a chemical reaction, a chemical equation must have the same number of atoms on each side of the arrow. So somehow we need to have the same number of oxygen atoms on each side of the arrow. If we add a 2 in front of water, what that means is now we're able to change the coefficients. So if we add a 2 in front of water, that means we're doubling the number of hydrogens. So we now have 4 hydrogens. And we have the 2 oxygens that we want. So now the oxygens are balanced, but now we have unbalanced hydrogen atoms. We can fix that by adding another coefficient. In this case, we're going to put a 2 in front of hydrogen gas. So we now have 4 hydrogen gas molecules. So now we have a balanced reaction. 2 hydrogen gas plus oxygen gas yields 2 water vapor. Remember that only the coefficients can be changed, not the subscripts. Here's a sample problem. Balance the following chemical equation. Here we have methane, CH4, reacting with oxygen to produce carbon dioxide and water. We first take an atom inventory. We have 1 carbon on the reactant side and 1 carbon in CO2 on the product side. 4 hydrogens in the reactant side in methane, CH4, and we have 2 hydrogens in water on the product side. On the reactant side in oxygen, we have 2 atoms. And on the product side, we've got 2 atoms in carbon dioxide and 1 atom in water, so it's actually 3. So we need to balance this equation. So far, the only thing that's balanced are the carbons, so let's leave them alone. Let's try balancing the oxygens. Well, actually, balancing the hydrogens. If we put a 2 in front of water, we now have double the amount of hydrogens, or 4. So the hydrogens are balanced. But now we've got more oxygens on the right-hand side. Notice that we have 2 oxygens in carbon dioxide and now 2 oxygens in water. So overall, now we have 4 oxygens on the product side. So now carbon is balanced and hydrogen is balanced. To balance the oxygen, what we need to do is just double the number of oxygen gas molecules in the reactants, and that will make 4 oxygens. Now everything is balanced. We have the same number of atoms at each side of the equation, and it's reduced to the least common multiple. Thanks for watching the video. If you're interested in a free copy of my book, Solving Mole Problems, go to purplestoic.com and also send me more helpful videos. This is Melanie Fine of Chem in 10.